Okay, good morning. Welcome to our final week of the semester. Next week is finals week. Last week was a test. The test grades have been posted on Moodle. At first, I realized that after talking to one of the students in today's office hours, I realized that the settings were wrong for the test and no one could see their actual results on each of the questions. Um, and so I've changed my settings on the test so you should be able to see what you did on each individual question. So last week, our final lecture was on recursion. Recursion is an idea that is used quite a bit in more advanced programming and in advanced languages. Lisp is based on recursion. C++ and C, Python, Java, they all have recursion. And recursion is this natural way of thinking about things mathematically that allows you to write code quickly and compactly, but it is not efficient. Iteration is always more efficient. And so if you can do something iteratively, then you should do it iteratively, that is by loops instead of by recursion. But both are a way of doing repetition. So when it comes to when it comes to assignment sequence decision repetition, in repetition we have loops and we also have recursion. Okay. Now today's well, that recursion lecture went quite long. It was an hour and 8 minutes long, which is like 18 minutes over what a normal lecture is supposed to be. Today's will probably be shorter because I am going over your test number 3. And so I'm going to go over what the answers were that I was looking for simply by taking the test myself. So I'm going to cut video and then I'm going to share out the screen. And what I'm going to share out is Moodle. And this is my view of Moodle. There's test administration right over here. I've already clicked on the test, and now I'm going to do a preview of the test. And that allows me to take the test as if I were a student. So when I click on preview, okay, this is test number 3, blah, 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 timed quiz. You have 1 hour, and I'm going to start the attempt. Okay. So the first question was actually a 0-point question, and it was just simply to say, I agree that I have neither given nor received unauthorized aid in this examination, nor have I concealed any dishonorable behavior, including, but not limited to, cheating, fabrication, plagiarism, and obtaining an unfair advantage as described in the LSSU's Student Handbook's Code of Conduct. And so you had to hit true there. This is a modified statement of the Michigan Engineering Honor Code. I used to have to sign that statement on every test I took at the University of Michigan. And so that's where that comes from, this wording. Okay, so with that, now I'm ready to take the test. So I hit next page. Describe how a stack and a queue are the same and explain how they are different. So they are both linear data structures that are typically, but not required to be, typically dynamically allocated. They utilize the same or very similar building block, usually a struct Okay, so that's how they're all the same. How are they different? So a queue adds to the data structure. That should be at the back end, while a stack adds at the front / top. Queue is a first in, first out FIFO data structure, while a stack is a first in, last out data structure. And I missed my parenthetical there, so I'll go back and put that in. Parenthetical FILO. Okay. That's pretty much it. So next page. Okay. Give the answers to fill in the following table. Label your answers for each cell as answer X. I've given you the answers in red for 2 of the cells. A couple of you were really confused by this, and this is exactly the table from one of the lectures. And I think I made comment of that. So what is answer 1? Answer 1 is what position do we insert in a stack? And that would be front / top. Okay. Answer 2. The number of insertion special cases. Well, it turns out that there are 0 special cases for insertion into a stack. Answer 3, position of removals. That is, again, the front or the top, whichever you happen to call it. Answer 4, the number of special cases for removal. Okay, well, the stack has 1 special case. That's an error case, and that's when you try to delete or pop an empty stack. Answer 5. Okay, answer 5 is, where do I insert in a queue? I insert at the back. Okay. Answer 6. The number of insertion special cases. Well, for a queue, it turns out there's only 1. That's the first thing into the queue, and that's because you have to alter both head and back, or front and back, whichever you call them. But from there on, insertions are fine. Okay, so there's no special casing on those. Answer 7. Position of removal is at the front. We don't call it the top usually when we're dealing with a queue. Answer 8. The number of special cases for removal. When you delete the last thing, and when you try to, or dequeue the last thing, or when you try to dequeue an empty queue. And so that means there's 2 there. Answer 9 is the number of insertion special cases for a linked list. And it turns out there's 3 of those. After the last node, or at the end, in front of the head, and into an empty list. So there are 3, okay? And then answer 10 is where can you remove and that is anywhere. The same as insertion. You can insert anywhere, you can delete anywhere. Okay, that's it. That's what I was looking for on that one. And that's what would have gotten you full points. Okay, next page. Explain why we should use accessors, getters, and mutators and setters rather than just allowing direct manipulation of data members in our class. The first one is data hiding, okay? So that is the data, the abstract data type. Whoa, I was answering the wrong question. Data hiding. It is about data hiding. And security. Okay, and so you had to hit on both of those ideas. Data hiding, if I were to expand upon that, is the user doesn't need to know the underlying organization of the data. Security. Both the accessors and mutators, we can check boundary conditions, authorization. And I'm a Trinitarian, so I'm going to sit here and try to think of a third reason or a third way that this affects security. So we can check the boundary conditions, authorization, and this is a concept that I wouldn't expect you to get, but somebody did. Data sanitization, that is like string data. Does string data have in it, buried in it, an SQL database query? This is called SQL injection. And so one of the ways to avoid that is to do data sanitization. Okay. Man. Spelling has got that wrong, but there we go. So you had to hit both data hiding and security. Okay. This was the only automatically graded question on the test. For each item in the following class specification, choose the correct type of item. So this is a constructor. Okay. This is a destructor. This is causing problems on my screen. Set ID is going to be a mutator. So all your setters are mutators. I just want to point something out. If you go back to the previous question, mutators, setters, accessors, getters. So here, notice that the mutators have set in them, and the accessors have get in them. So here's set, set, set. Each one of those is a mutator. Get, get, get. Each one of those is an accessor. Sorry about this graphical, the drop-down menu causing problems on the screen. Okay, and then these are data members. Okay, so here we have a constructor, a destructor, 3 mutators, 3 accessors, and 3 data members. That's 11 total things in here, but I graded this out of 10 points. So there were fractional points, and I rounded them to the nearest whole number. Okay. So there's all your answers for this question. Next question. What are the differences between statically allocated memory and dynamically allocated memory? Statically allocated memory has its size determined at compilation or compile time. Let's just say compile time. And you can't change the amount of data it can store. Dynamically allocated data. Memory. Excuse me, memory. There we go. Is determined on the fly during running of the program. Its size can grow or shrink as needed. Memory is managed by the programmer using new and delete. Okay. And I could put in parentheses on those because those are actually functions built into the language. Okay. So that's what I was looking for. The idea that statically allocated memory can't change its size. Now, yes, it can change its size. There are some unholy things you can do with statically allocated memory that have been incorporated into the language by later revisions of C++. They are evil. They are the 7th level of hell spawn demon, okay? They make things really ugly in the runtime of the program. And so I don't talk about those things. It's just, I had a colleague who loved doing this, resizing arrays. No, I don't do that. Okay. So there you go. That's what I was looking for. Next page. What is a seg fault? So a segmentation fault is caused by attempting to access memory that either doesn't exist or for which access is not allowed. For you. So you might be trying to access memory that the operating system is set aside or another user has set aside, and that's outside of your segment of memory. So that's what a segmentation fault is. These are pretty easy to create. All you have to do is try to use a null pointer. So something like this. So there's 2 lines of code that will guaranteed create a seg fault. I declare a integer pointer. I set the pointer's value to null, so it's pointing at the, at memory that is not accessible. And then I try to increment that pointer. Okay. Actually, no. There we go. So dereferencing the pointer and then trying to increment that. So that'll get me a seg fault. You didn't have to do that for this question, so there's the actual answer I was looking for. Okay. Next page. Write the specification of a struct called LL node that can be used to build a linked list. Use the class list item type as the data in your struct. Struct LL node list item type data. Whoa. And then LL node star next. That's it. That's all there is. And this looks exactly the same as the struct that we use for stacks, the struct we use for queues, and indeed the struct that you need to put into your program for program 8. Hint, hint. This is exactly the struct that you need to put in your class, your linked list class for program 8. Hint. Next. Write the code needed to declare an input file stream. Then open that stream using the file name p4.dat, and then read from that file stream, printing out what you read. The file p4.dat contains integers, 1 per line. You're to use the following variable definition, int temp, for your input. Do not write a function, do not write a main, do not write code to check if the file was open correctly, just the code for which I asked, which is about 8 lines of code if you count the curly braces as separate lines, not counting blank lines though. Int temp, if stream in file. That's 2 lines of code. In file.open p4.dat in file temp while not in file.eof cout temp emdl in file extract temp one, 2, 3, 4, 5, 6, 7, 8, 9. 9. That's it. And since I told you you can use the following variable definition, that meant that that really didn't need to be put in there. And so I didn't mark you off if you didn't have it. And there's your 8 lines of code. That's it. That's all I was looking for. Complete the whole thing. What are the benefits of storing application data in its own class versus storing it in the class for the ADT? The ADT should not know about the data that it is storing. To do so, or to require that, so if you require that, then you can't reuse the ADT class code. And I'm just going to make that explicit, programmer. So the application programmer should not know about the underlying organization of the ADT, nor should they get access to memory addresses, i.e. pointers. And all of this is part of encapsulation and provides both the ADT and the application data with some measure of security. Okay, encapsulation is one of the tenets of object-oriented programming. And so encapsulation is making sure that classes don't have more information than they need. Okay, and this does provide a fair measure of security. It is not absolutely secure. There are a lot of issues that you're going to run across in creating secure code. Accessors and mutators get you some measure of security. Separating the classes, the application data from the abstract data type implementation, those get you some measure of security. But plain and simple, there are other ways to exploit systems. And so building secure code is actually a really difficult and involved process. It's not something that comes easily, and that's why we have an entire course on security. Okay, next page. And this is our last question of the test. Write code for a queue destructor. Make sure that all nodes are deleted. Assume that the struct used in the class is called QNode, okay? So all we have to do is write the code that goes in the destructor. I've given you the skeleton of the destructor. And so the code that goes in there, I'm gonna indent it just because I would indent it in between these two curly braces. I'm going to need a temp pointer. And so that's going to be of type QNode star temp. Okay. Actually, I don't even need to do that. I'm going to write it two different ways for you. Whoop, can't use the tab character. Again, can't use the tab character. I'm actually gonna alter this just a little. So let me walk through this and make sure it works. I create a local variable called temp. It's a pointer. I put that in the wrong spot. This is why I proofread and why you should as well. So while front does not equal null, I set temp equal to front, I set front equal to front arrow next, and then I delete temp. Okay? Yep. I'm pretty sure that's the way I want to do it. Way number 2, while not is empty. I just run a while loop while the queue isn't empty and I dequeue. I just throw away the return value from dequeue. I don't need it to be placed into a variable. And so that'll walk all the way through the queue and delete everything. And as long as I've written my dequeue correctly with the correct delete in there, I'm fine. And in fact, the code for dequeue looks a lot like that. So, not quite. We have to save out the data, but the pointer stuff looks exactly like that. So there's two different ways you could have written that code. And that is that. So that is everything. That's, yeah, that would have gotten you 100 points on the test. Okay. So with that all said, I'm going to shut that down. I'm going to stop my share. I'm going to pop over here. And I'm going to end the meeting. As far as I can tell, I am going to write the final exam the same way. I'll allow you to use your textbook. But just like this test, using your textbook is not going to be that great of an advantage simply because of time. You see how long it took me to type in all of those answers, and I knew what the answers were because I had written the questions. And so when I finish out on this, I think that was probably 15 minutes or so to write the solution, maybe even 20 minutes. Okay, so when you get to that final, You're going to want to be well studied. You're going to want to study the 3 tests, go back over the correct answers for those, and make sure that you understand the ideas, the concepts. And that way, when you take the final, you're not going to be sitting there going, oh, oh, shoot. I know that's in here someplace. Where is it? Standard template library. No, that's not it. Inheritance, no. Recursion, no. Pointers and linked list. Head accessing node data. The arrow operator. That's not going to help you. You're going to waste a lot of time doing that. Okay. You want to say linked list. I know how to do that. I did program 8. Got it figured out. Okay. So study your programs, study the tests, and you'll do well. Not a guarantee. Caveat emptor, buyer beware. Your mileage may vary. A professional programmer on closed course, do not attempt at home. If you do not study, it is a guarantee you will not do well. So catch you again tomorrow.